Welcome to Analyst Crossfire, an ISC 17 panel featuring expert voices from the international supercomputing community giving their reactions to some of the top HPC trends as discussed at this year's conference. I'm Addison Snell with Intersect 360 Research, and I'm the moderator of this panel, having selected 4 experts with different perspectives from across the HPC community. These 4 have volunteered to play the analyst with me by sharing their personal opinions on current and future supercomputing trends. I'm very excited to have this year on my panel an expert from International Exascale Program from the U.S. University of Chicago and Argonne National Labs, Rick Stevens. Rick, thanks for being on the panel. And then pinch hitting for Depay-Chan, who is detained, Martin Palkovich from the Czech National Supercomputing Center has volunteered to step right in and take these questions on the fly. So Martin, I'm especially excited that you volunteered to jump in. I'll call on you, I won't go to you first right away, I'll let you warm up to them. These 2 are joined by 2 experts from noteworthy HPC technology companies. First is from HPE, which is the leading HPC systems company by revenue worldwide. Vice President General Manager for HPC, Bill Manel. Bill, thanks for being here. And finally, from Penguin Computing, a company with a growing presence in HPC and hyperscale, Vice President of Advanced Solutions, Jussi Kekkonen. Jussi, thank you for joining the Analyst Crossfire panel. Panelists, thank you for joining me for ISC Analyst Crossfire. The clock is running, and we're going to get started. Topic number 1 is AI meets HPC. One of the biggest topics at ISC this week has been artificial intelligence and the overlap of deep learning with HPC. Certainly these applications are consuming HPC technologies and influencing roadmaps. The question is, what effect will AI have on existing, established HPC applications? How are things going to evolve? Bill, I'm going to start with you.
Yeah, I think what you'll see over time is the fact that as we gather in more data, and we'll use the data as a basis for building essentially the equations. Now we'll have 2 ways of looking at systems. We'll start with equations and use modeling to create data, and then we'll start with data and use AI to basically create equations. And if I talk to customers in especially heavy manufacturing, that's what they expect to do. They'll do much more product development that's based upon gathering real-time sensor data as the thing flies or the thing drives from that perspective. So I think it's going to change fairly significantly. I don't think the applications will go away, but I think they'll be supplemented.
They'll be supplemented in terms of big data, not big data, artificial intelligence influencing how the HPC is done.
That's correct, yeah.
Jussi, what do you think?
Okay, does this work?
Yep, you're good.
Very good. So basically, we have deployment experience from both from top 500 class conventional HPC environments as well as recent large-scale AI environments, AI analytics environments. And we tend to consider, from kind of deployment and operational perspective, we tend to consider AI as a special case of HPC. It's or subcategory of HPC, if you will. And granted, AI does drive some, more recently, AI does drive some specific silicon-level design features and so forth. But just looking at the broader picture, a lot of the surrounding technologies for fabric interconnects and for storage, to enable these analytics, the interconnects and storage they are very much similar. Basically AI does create a broader market, higher demand for higher unit deployments for storage and interconnects, and we see that as a net benefit also for HPC, for conventional HPC environments.
Yeah, I get that there are similar demands. I haven't really heard much yet in terms of specific things that are going to change in HPC. Martin, I said I'd give you a quick respite, so let me hit Rick first, then I'll come back to you.
Okay, well, I think it's going to completely transform HPC applications. So in some cases, it will wrap these applications, so it will control the parameters, it will control the inputs to HPC, so HPC will become a subroutine that AI uses. In some cases, AI will get embedded in these applications as cheaper function approximation for various physics or other components.
Do you have specific application ideas in mind?
It's already starting to happen in climate, we're starting to see it in cosmology, we're starting to see it in computational biology, fluid mechanics, combustion. I think it's going to hit everything. It just depends on how open-minded the people are building the apps or maintaining the apps. And then finally, I think in some domains, it'll just completely obliterate the applications. Because where we have relatively poor predictive models today, and we have enough observational data or data from other models or data from experiments, that we should be able to do design processes in particular that are almost entirely driven by the AI pieces. So I think it's going to be completely transformative at that level. I think the second part is that the architectures that are good for AI are pretty crappy for traditional HPC. So if we see a big movement towards low precision, tensor operators and so on, and that becomes the dominant hardware platform that vendors are targeting, and I think they are, then you're going to see a slow starvation of traditional HPC requirements in the hardware, and they'll have to adjust to that.
I like your point about the quality of the models, especially as it pertains to precision. We're going to hit that later in the panel, but I want to get to Martin here since he was brave enough to step up. What do you think about how HPC gets influenced by AI?
I mean, my opinion is...
Okay.
So that AI is extending the HPC. So I mean, we see several examples already. I think it was supercomputing last year or something, where in Japan they model the tsunami and they also analyze Facebook and so on, do some deep learning and do better precision with the models. Also, like when we look at the pharma industry, we have several projects with the pharma industry. They go at a traditional approach where they do like computational chemistry to design the drugs, but then they start to have a lot of deep learning applications where they just they have the matrix where they have basically the different medicaments, and they have basically how they react. They have some experiments, and with the deep learning they feel the matrix. So I think it's extension and the combination is important, but then we hit again the architecture thing that was mentioned by previously. Yeah.
So you see Penguin has these OCP configurations that are kind of these tweeners between hyperscale and HPC. Are you seeing that kind of cross demand, and what kinds of HPC applications do you see that pull in?
We are definitely seeing in many ways convergence of let's say commercial cloud and hosting provider environments and technologies used in those environments and HPC environments. That applies both to the physical infrastructure, the data center layouts, and also the operational model, which is more around software and workflows.
So Bill, I'll give you the last word on this. Are you seeing particular customer demand from HPE to start building AI into the HPC side?
It's probably early for more traditional customers. I sell into a lot of service providers as well, and so we're seeing a high demand in service providers right now. So they seem to be consuming a lot. Others are starting to sample, starting kind of small and kind of moving up from that standpoint.
One I expected you to hit for strength of HPE that I didn't hear you say was finance. That's probably the area we've seen the most where they're really using AI. I think that's going to revolutionize a lot of these pricing applications in particular, where within 10 years we might do away with the idea of a risk tranche. I think you'll have a personalized interest rate before you have personalized medicine. I'm also excited about AI in the loop instead of engineer in the loop kind of simulations, but the clock's moving on and I'm not answering the question. Issue number 2 is exascale software. We've heard a lot this week about plans for pre-exascale and exascale systems, which are drawing steadily closer. If we succeed in the hardware, the question is, how ready is the software for exascale, including the operating environments, developer tools, middleware, and applications, and what more needs to be done? I want to start down there with Rick this time.
Well, I think we have to take a serious look at any practical exascale machine from a cost, power, or whatever is going to be built on some acceleration technology. And I would say one of the very little secrets is that even though we have big machines with accelerators, we're still not fully acceleratorized our applications. So that's a big piece that still has to happen. There needs to be a lot of work done, whether it's CUDA or something else, vectors, ZM5, whatever. That needs a lot of work. I think at the OS level, I'm less worried about it because most of the exascale design points are extensions or extrapolations from the pre-exascale machines, and I think the middleware community has more or less got that under control. Probably the third piece, and this ties it back more to the first question, to the degree that exascale machines have to be looking forward. The workload on those machines is going to be balanced between simulation, big data, and deep learning. And right now, those three domains essentially have different software stacks. And so I think the biggest challenge is an integrated software stack followed by optimization of applications for whatever the accelerators are for that time frame.
I love your point that we might not necessarily be there with the software, with the systems we have today already. Martin, what's your thought on software readiness for these large systems?
I believe it requires a lot of education because basically how we write software it's still more or less the same, right? So those machines will require really a lot of training, a lot of understanding how those machines will work, and definitely also the other point is to have the whole ecosystem, to have the co-design and to have the whole ecosystem, not only software, hardware, etc. separately, but that everything works together. So that's important.
Do you have an idea of what we can do to speed that along from the co-design standpoint, where this knowledge is going to come from?
I mean, for HPC is a little bit difficult because before I was working more in embedded, and there it's simple, right? Because there you have one tool where you create software and hardware. You cannot do it in HPC. I mean, the hardware loop it's much longer, right, to do co-design. So that's why you have to think very, very carefully when you design your hardware and basically also think about the software in the future.
Great, hitting the vendor side of the table. I mean, you start building these large systems, whether it's exascale or hyperscale. So what do you think about the software readiness, and do the hardware vendors have a role in promoting that, you see?
So looking at, let's say, a typical or average system today on top 500 list, those are typically in the order of 0.01 exaflop systems. And anybody who has already deployed or operates, manages that type of compute resource knows that there's a fair degree of complexity, a lot of moving parts, so to speak, parallel execution engines, fabric links, and so on. So basically, you can never, even with today's machines, you can never assume perfect 100% uptime on system level, and this is further amplified in any kind of practical exascale system. So one implication is clearly that software needs to be written, and the infrastructure software needs to be written to work around individual low-level component failures. Those need to be taken for granted. They're going to be just a fact of life, and that's probably going to be reflected to some degree also on application layer. And this is basically maybe an example where exascale software stack will borrow some influences and ideas from commercial hyperscale cloud computing environments that exist today.
Bill, HPE is one of the companies that got a path forward award on the hardware side toward exascale. Do you have thoughts as to the software readiness as we head there?
Well, certainly to Rick's point earlier, I think as you look out, say the exascale machine happens in 3 to 5 years, I think as more and more of we have this confluence of big data and AI and HPC and how that plays together, I think that's going to change applications. So I think we have to get better at that. I think we have to get better at increasing the efficiency of the applications. We'll need to use accelerators, and how efficient can we use those accelerators? I think along the system software and BIOS side, I think we've got to get more efficient in terms of managing those, making them more self-aware and self-healing from that perspective. So a large exascale system obviously is going to have probably a failure every hour when you look at the amount of components. So how are we going to manage that and make that easy to keep up from that perspective?
I agree with that. The notion that you're going to avoid failures, you just can't get there. The idea is how do you manage the failures gracefully in this context. I want to get back to Rick with one wrinkle on this question related to path forward, which is that we noticed that on the hardware side, you give grants to the leading companies that are providing hardware toward exascale, but on the software side, the grants get distributed between government and academic research labs to design open source software that in many cases will compete with commercial software that already exists. What do you think of the different approach here in terms of the commercial companies for the hardware versus the open source software?
Well, I think I can't speak for the entire project, but I think our sense is that we want the vendor software to be as open as possible. We want environments we can build. We want to freely integrate open source software with the vendor software stacks. mix and match. So to the degree that the vendors are getting on board with that model, I think future ECP investments might be oriented towards the vendors. I mean, the historical model investing from the DOE has been investing in software projects that produce open source. And so that's been one of the stumbling blocks with investing in proprietary software. That, we're still interested, of course, in maybe there's proprietary, very, very low-level software that doesn't make sense to be open source, and that maybe could be funded as part of a hardware-oriented program. But I think to really embrace significant investments in software, everybody's got to go open.
I've been hammering this topic because we use this term exascale, and ultimately the difference between exascale and exaflop has to mean there's some productive application running at that level. So I'm trying to promote the idea of where's the software in all of these exascale programs. Issue number 3, remember big data? Nobody has talked to me once about big data all week, and this is like a major topic not that long ago. What happened to big data? How have things changed, and have things changed enough? Bill, I'll let you go first.
I think what happened to big data is the media got bored of it. So big data is alive and well. And I hate to sound like President Trump, but I have to blame the media a little bit on this one. So they lost interest. We've got customers that are using big data at scale every day and production from that perspective. So
when you say they're using big data at scale, what does that mean specifically?
That means they're in the neighborhood of 100 to 150 to 200 petabytes of data. So they're regularly accessing it, using it to make decisions, those sorts of things.
So big data in this case equals a certain number of bytes. Yussi, what do you think about big data? Are you seeing it? Is it a solved problem? Where are we?
So big data as a marketing term in media, I think it's probably not as visible as it used to be. That being said, I think my current interpretation of the term big data is that it's being basically relegated to mean this set of technologies that's used to collect and manage and ingest vast volumes of data for modern HPC and also AI applications. So basically what we are seeing is that the deployment of big data type technologies, both hardware and software technologies, that's very much alive and well, and we're basically seeing the attach rates for large-scale storage in conjunction with HPC and AI compute resources to steadily increase and ramp up.
Okay, so what I'm hearing is that basically we had a big marketing message that kind of started to fade away, and there were some different solutions there, but things haven't changed that much. Martin, what's your view on big data? Did it really change your workflows?
Maybe I will answer another question. So why the big data are not so visible anymore, right? So I think the people start to be more careful when they are speaking about big data, because often when I heard about big data and then I tried to find out what is behind it, it was one USB stick, right? So people are very careful about it now, and I liked what was said, it was, I think, in the morning session, one of the morning sessions, that really big data will come when the machines start to talk to each other, right? That the human cannot really produce the big data when the human uploads pictures or something. That's not the big data. Once the machines start to talk to each other, that will be the big data that we have to then process and analyze, right?
Rick, you were nodding along with part of that. Something struck a chord.
Well, we used to define big data as data that's bigger than the scalability of the analytical tools that are used to try to analyze it. So it could be a USB stick if the tools were really terrible. I think what's happened is part of this media burnout, part of it was we were never able to, people pushing big data as a concept weren't able to articulate finite transformations in society in the same way that the AI rhetorical frame does, right? So big data wasn't going to give you self-driving cars, AI is giving you self-driving cars. Well, of course, behind training self-driving cars is a big data problem, and pretty much any large-scale AI application has a significant data problem behind it. But there's many data challenges, whether it's data coming from telescopes or from microscopes or X-ray sources or accelerators of various things in science or data uploaded to Facebook and social media, that is still ongoing, and we have lots of processing needs that in fact are not related to AI. I mean, just keeping up with streaming data processing transformations is something we have to be focused on, which is why when I talk about it, I think of three distinct pillars: HPC, data, big data, so we just say data, and then learning. And because the data has many aspects to it that isn't related to AI, isn't related to simulation. It has special requirements in terms of system architecture, system software, middleware, algorithms, and so on that are distinct from those other things. And so, but I think the reason the media got tired of it is that AI is just grabbing all the headlines, and that's perfectly fine. The media doesn't actually produce any advances in big data. It just
So does that mean we can cancel our projects to start moving all of our HPC onto Hadoop?
No, well, Hadoop never was designed to be very scalable, and Spark, of course, made some improvements, and now there's things beyond that. So these
I would
simple
swear people
frameworks-
talked about Hadoop at this
They talked
conference
about
not
it
very
forever
long
because there
ago.
was nothing else to talk about and people didn't understand it. But there was also this notion that analysis was being reinvented in the non-scientific world with technology that everybody thought was some kind of panacea. There was always this notion of trying to imagine some simplistic model is going to fix everything, right? And Hadoop became synonymous with the way you approach big data, or Spark then became synonymous with it, and these are all one approach out of many that are needed and not particularly optimal for the hardware that we believe will exist in the next few years. So,
I'll tell you, one thing I think happened from our perspective as analysts is people weren't spending any additional money. People were, trying to incorporate big data into their workflows, but it didn't wind up being a big growth rate for a lot of the people chasing it.
Disk drive prices are pretty low. Hadoop is open source, right? People repurpose systems, right? They put VMs on. I mean, sure, people are just going to do whatever they have to do. I think on the hype curve, it went very fast, but it was very, very difficult to explain beyond the fact that it was awesome and
The
big.
only measurable market effect we saw is a slight bump in storage revenue that had to do with people mixing flash into their overall storage hierarchy, buying the same number of bytes capacity total, but some of it was flash, so the total price went up. I hope you liked those really long answer questions. We're going to move on to the speed round. Speed round question number 1. Rick, this topic you already kind of broached, so I'm going to hit you first. Is there a role in HPC for single precision or even half precision computation?
Yeah, absolutely. There's many things that we need to apply high performance computing to besides PDEs that could fully exploit low precision arithmetic. Whether agent-based simulation is one of them, for example. A lot of discrete problems can be addressed this way, and multi-precision approaches to even PDE solving can exploit abundant lower precision arithmetic. It's a little bit more challenging than just hitting everything with 64-bit, if it's free and easy. But I think we're going to have to address this because the machines are going to be very good at this low precision stuff.
Martin, are you going to start moving single and half precision into your workloads?
Definitely there is a room for that. When we look at ASICs, right? So ASICs are so efficient and so good because you can define the number as large as you need. And more granularity in HPC, this is half precision and so on, so that would be great, so definitely.
Vendor side, here's that signal. Are you going to start working single and half precision into your offerings for HPC, UC?
We are already seeing interest and deployments use of less than double precision arithmetics on specifically on workloads related to image and video stream processing, surveillance type applications.
Bill, same question for you.
Yeah, absolutely. Seismic processing, 8-bit microphones that gather data.
There's a great specific answer. Love it. Keep going.
You can't make up data, 64 bits, you don't need it, right? So we're seeing that a lot.
Another thing I've heard is that, related to your earlier point, Rick, sometimes your model isn't that good to begin with, and here you're doing a lot of double precision calculation on a model that could improve. You're better off, you're dropping flops on the floor doing extra calculation on a model that needs work. Speaking of software, commercial software, we're talking about open source and all of the emphasis on open source development plus architectural diversity, stressing the open source community. How does this look, future outlook for commercial software for HPC? UC?
Again, speaking from what we see us and our customers deploy and ask for, increasingly the software packages, both kind of infrastructure management software as well as application domain and libraries, it's increasingly open source software, often open source software with commercial support packages or support contracts, subscriptions. So To me, it seems that increasingly the item of value is really the subject matter expertise, the application domain expertise, and software, which is often open source software, is the delivery vehicle.
Bill, HPE offers some commercial software. What's the future here?
But it's mostly open, so we've tried to take a direction to being open as much as possible, build a lot of our cloud stuff on OpenStack, and so to the previous point, I think it's all about open source software and then offering the services, support, and expertise around it. I think that's just kind of the fashion right now. It seems to be the thing that's taken off.
Martin, what do you think is the future of commercial software?
In industry, I think bright, because we see that the industry loves commercial software from ISVs and so on. So I mean, they are experimenting also with open source and so on, but they still have the commercial software as a reference. I mean, we experience it when we work with the car industry. So they really go for commercial software and like ANSYS phone and so on, and then OpenFOAM, it's just, I mean, they are using it, but it's just the second option. So
well, that you made a great point, because Fluent is the #1 ISV application in the market, but OpenFOAM is the fastest growing. Even in commercial sectors, there's a transition to open source. Rick, you're nodding along. Go ahead, last word.
Commercial users need support. That's the #1 issue. Whether it's open source or proprietary is less important. I think over time they want to go open. Everybody benefits from it being open. We need to build more robust support organizations, deeper ties with the research community that can feed this and smooth out and accelerate the ability for these commercial packages, even if they're open, to scale, because that's really a challenge right now.
Ultimate short answer. We're going to church here. I'm looking for faith-based answers. Do you have faith, belief in each of the following? I'm going to start with ARM-based supercomputers. Bill and Jussi, I hardly have to ask you. You both just want to say yes?
Yes.
Yes. The other two guys, ARM-based supercomputers. Do you believe in this?
Yes, in the longer term.
How long?
2020?
2020. Rick, ARM-based supercomputers.
Yes, with appropriate acceleration, otherwise they're probably doomed.
All right, stay down at that end of the table. All optical interconnects. Are you a believer, Rick?
Yeah, I'm a believer.
Do you have a time frame?
Probably later than we hope.
Okay, start coming back this way. Martin.
I would answer the same as Vic, so yeah, I'm a believer.
Vendor side, Bill, believer in all
Oh,
optical?
yeah, absolutely. Copper's dead.
Copper's. How soon is it dead?
Probably 2-3 years out.
2-3 years out. Jussi, what do you think of all optical?
Yes, it's happening. The investment and innovations have been happening.
All right, we're going to start getting harder then. Universal quantum computing, Bill. You're a believer?
Oh, yeah, absolutely.
Jussi, do you believe in universal quantum computing?
I believe in commercial quantum computing. Whether it's going to be universal, I'm not sure.
Okay, user end of the table. You just lining up to buy your universal quantum computer?
No.
No, not a believer.
We're lining up to make one. I think it's absolutely going to happen. I think if it's not universal, it won't be particularly interesting. And I hope that it happens soon, and then we'll have some really interesting accelerators for our ARM-based supercomputers.
You want to get really interesting? How about self-aware AI? You a believer?
We are. I mean,
self-aware or
self-aware,
believers?
and we're AI.
Can you prove that you're self-aware?
No, absolutely. I think it's eventually going to happen. I don't think it's necessarily going to be evil.
Well, I hope not. Martin, you believe in self-aware AI?
Yeah.
You do? Do you think it's coming fast?
No.
No. Okay, Jussi, what do you think of self-aware AI?
I don't expect there to be a singularity event in my lifetime.
Not in your lifetime, Bill. You believe it?
Yeah, I believe it. It'll be a while.
It'll take a while. I'll tell you what I believe on that. I believe we'll create AI that's good enough that you won't be able to tell whether it's self-aware or not. And then at that point, whether it actually is becomes more a question of philosophy or perhaps religion. All right, last question is our traditional one up, one down. From your observations at ISC, can you tell me, each of you, from your experience this week, what was one thing that surprised you in a positive way or better than you expected, but also one thing that you expected more and it needed to do more this week? Bill, I'll start down at this end.
Sure. I think the thing that surprised me was how much AI has come in. You know,
That's
if you
your
look back
positive.
That's my positive thing. Over a year ago. Probably the negative thing, I guess.
We were talking about machine learning last year, so this is building on that trend. I looked, we had slides on that last
we did.
year.
Okay, so I missed it. Sorry. So it was my opinion, probably down, I guess, it feels like, in terms of the activity around the trade show floor, not quite as much, maybe it just wasn't as interesting.
They set an attendance record, man. You gotta do more to draw people to your booth.
I guess so.
All right, UC, what do you think? One up, one down.
Well, we basically this year, 2017, it's going to be multiple very interesting silicon and silicon platform announcements. A lot of progress on roadmaps. Basically, platform wars are in some ways on again. And
I'll give you 10 points for that answer because we not only saw a lot of announcements around ARM, but I thought one of the more interesting announcements that slipped almost under the radar was Wuxi saying there would be commercial Sunway Micro based on Taihu Light that they were going to sell. So that kind of came to me out of nowhere. Sorry, go ahead.
Yeah, and that's also the kind of competitive, the active development and platform options. That's also results in a lot of just increased interest, questions from the audience, questions from the visitors at the show. So we're definitely seeing good attendance and good, very high level of interest.
All right, Martin, you're our pinch hitter today, so I haven't given you a long time to think about this question, but we're looking for something that surprised you positively and something that you still think we need more from.
I mean, positively, so as mentioned, AI was very visible because also there was a special track on the deep learning, the whole day or almost the whole day. It was very visible, and the negative, that I will skip.
Well, that's fair because I didn't give you time to prepare on it. So we'll go down to Rick. Last word is going to be yours on this. One up, one down.
Okay, so probably the most bizarre thing I've seen was this 40 megawatt data center in Georgia that's doing Bitcoin mining.
So most bizarre. That's not an up or down, it's just over
because
there.
it was bizarre. I think probably the thing that was waiting a lot more from is I think the top 500 shifts were really boring. No offense, Thomas, for his machine, but not a whole lot's visible in the top 500 machine.
Well, is that just pent up stuff? We're going to see a bunch topple in November.
See, right? Maybe we'll have to do this again in Denver.
I think that's certainly coming. I'll tell you, well, I was already talking about my positive things. I thought there were a lot of new platforms, and especially around the architectural diversity. On my downside, if you're going to do that, I really wanted to see more on the software side. We need to see more on the programming models and application development going forward. All right, that's the end of our topic. Panelists, thank you. That's going to conclude our Analyst Crossfire. Audience, please join me in again thanking my panelists, Bill Manel, UC Kekkonen, Rick Stevens, and especially my pinch hitter, Martin Palkovich, who stepped in at short notice when we were a panelist down. I really appreciate all of them bringing their expert views to this panel. I also want to thank the excellent ISC events team for another successful, record-setting in attendance ISC conference. I'm going to give a final wrap-up on our weekly podcast, This Week in HPC, and we'll see you again next year. Thank you.